Hello, welcome back to Cracking the Cryptic. We've got a puzzle called Two's Company, Three's a Crowd today by Sudoku Fan 87. All I remember about this constructor is I think they're Australian and a fan of K-pop from the first puzzle they sent us, or they changed pseudonym at some point. I'm not entirely sure. You can tell I'm not a fan of K-pop. If you watched a recent Connections video I did, I said the words in it. I mean, maybe there's some sort of movie called K-pop Demon Hunters or something. And I had no idea that I was genuinely naming an absolute monster movie at the moment. There we go. All the young know about that. I didn't. I do now. Goodness. Anyway. Let's not talk about K-pop. Let's talk about this puzzle. We'll talk about that in a moment. Let's talk about Connections, where you can watch crosswords content. You can see Connections. What did I say? I think I said the wrong thing. I'm talking about Patreon, where you can see Connections videos and crossword content. And there's a Sudoku hunt, first of the month. Every month we bring you something in Sudoku to try, and we will. This coming December will be no exception. So do join us there. It's very good value, as are our apps, which feature Arrow Sudoku, of course, and Line Sudoku, and Classic Sudoku, the latest one. There's also the Worms. Those are great. I mean, all are great fun, all very good value. SVEN'S SUDOKU PAD is linked under the video too, should you wish to support Sven. But the first link is to this puzzle, and I'm going to go through the rules and then attempt it. And come with me on a journey of discovering what Sudoku Fan 87 is up to. So, normal Sudoku rules apply. 1 to 9 will go in every row, every column, and every 3x3 box. Digits along an arrow, sum to the digit in the attached circle. Digits on a purple renban line must be consecutive and non-repeating, but can be in any order. So this is a set of 4 consecutive digits in some order. That's it. There's not a lot of rules. There's not actually a lot of long arrows. Give it a try on that first link. I'm going to start now. I'm hitting the wrong thing there. Let's get cracking. These are quite short arrows. I suppose these must add up to at least 10. Oh, interestingly, they couldn't add up to exactly 10, because that would involve them being 1, 2, 3, 4, and then you couldn't make up these circles in the same row with 2 digits that did sum to exactly 10, because you'd need one of them to be below 5, and they'd all have been used up. So these add up to at least 11, as do these, but that's not. Could it be 11? Then you'd have 1, 2, 3, 5 on the arrows. You'd have to have 4 and 7 in the circles, and that would work. The 4 circle would be attached to a 1, 3 arrow. Is the grid a face? Might be a few eyes and a sort of mouth here looking at us. Or in this column, we've got circles. These 4 cells on the renban all see these 2 cells. They're in the same box or column as all of them, so they must be outside the kind of tight little knot of digits on the triangular renban. There's not a lot of information here. There's definite similarities about columns too. I mean, obviously there's a lot of symmetry. Oh gosh. Okay, well, less than 2 minutes it took me to remember what I sometimes tell you. When an arrow exists in a Sudoku, I mean, there is a lot of triggers here, and they were failing to trigger me entirely, but I've now thought of set theory. Why? Because there are arrows which have the arrow in a different row and column to the circle. 2, because there are gatherings of the circles in things we can highlight. 3, because all these arrows are short. There are no arrows longer than 2 cells here, which is normally not a very helpful arrow. But when we apply set in the right way, I think it's going to be helpful. Right, well, I'm definitely taking these 2 columns as one set thing. Okay, I'm going to take these 3 rows as the other. So the good thing about set, or one of the many good things about set, which is set equivalence theory, is a really interesting way of analyzing puzzles. I mean, the puzzle will have been set up by the constructor to allow this, but this is definitely important. The really good thing about set equivalence theory is that you can compare different sizes of population with each other, and it's still potentially relevant. So I will try and explain that. I've picked on the rows and columns that give me contrast between the circles that are not in the same row as their arrows. And it's basically these arrows that I'm talking about, and their circles are not in their same rows. So what I'm now going to tell you, and this will probably do something, and I don't know exactly what it's going to be, but come and find out with me, is that the 2 green columns, obviously each one is a full column of the digits from 1 to 9, because that's Sudoku rules. The 3 pink rows are all sets of the digits 1 to 9. So we're comparing 3 sets of the digits 1 to 9 with 2 sets of the digits 1 to 9. So if I start eliminating common cells or common totals, which is what we're going to do since this is an arrow puzzle, I'm going to be left with equality with a difference of 45. If I can eliminate this cell because it appears once in the green and once in the pink, and it's clearly the same number both times. And now I've done that, still it must be true that the pinks add up to 45 more than the greens. And I'm going to continue doing that. So these are the overlap cells that are just a 1-for-1 relationship. Then I can eliminate this whole arrow. Its green circle must add to the same as the pink arrow cells. And then I can do this one. And then I can do this one. And we've got these ones down the side as well now. I can do that one and that one. And look, I'm going to be left with many fewer, well, almost no green cells. Oh, it's those ones we were looking at earlier. So the difference between the pink cells and the green cells in total is 45. I didn't mention that that is the sum of the digits from 1 to 9. It's a secret that I only share with my closest friends, so you're now on the inside. But these 7 pink cells that I've got highlighted add up to 45 more than these green cells, and they have their own constraint, and we've just worked it out already. They have to add up to at least 11. So the pinks have to add up to at least 11 plus 45 is 56. Well, these 3 could be 7, 8, 9 at the absolute maximum. So could these 3. That's 24 plus 24 is 48, plus a 9 in this lone central cell, in the only one in row 5. That's 57, and we're comparing that with 45 plus 11, 56. Oh, there is 1 degree of freedom between pink and green, and we're going to have to work out how that's going to apply. So the first thing I'm going to say is the 1 degree of freedom is from the maxima here. These could be 7, 8, 9 or 6, 8, 9. The same is true for this group, and this cell is 8 or 9. That's using the 1 degree of freedom. Now, here, 11 is the minimum these could add up to, but now there's a degree of freedom and it could be 12. We may, we might need to eliminate that degree of freedom before we can make better progress, even though we know that the pinks in row 2 and row 8 include the digits 9 and 8. Oh, I didn't put 6 in there. Okay, I'm going to think about row 3. Because it's very specific. What would happen if these greens did add up to 11, which is the only way that the pinks could use the degree of freedom, is if the greens added up to their absolute minimum, which we said was 11. Now we know exactly what digits would be involved. We said that the arrow cells would be 4 digits in the same row adding up to 11. That would have to be 1, 2, 3, 5. The greens would therefore have to include a low digit. They would be 4 and 7. So these remaining digits, let's make them yellow, would be 6, 8, 9. And is that a problem? You'd have 6, 8, 9 in those cells. Well, is it a problem because now we are trying to use a 6 in one of these rows? No, that shouldn't be a problem. Maybe there isn't a problem. Maybe that is what happens. 6, 8, 9 in the yellows. Oh, hang on. We'd definitely be using... Oh, we'd definitely be using an 8 and a 9 in row 2 because there's not enough latitude to not use 9 and 8. These either add up to 24 or 23. There's only one degree of freedom. We must use 9 and 8 there. These are, in this case, specifically 6, 8, 9. So we're using 8 and 9 there. And these, again, use 8 and 9. So these groups of cells would all use 8 and 9 3 times. And that would mean that 8 and 9 would have to appear in not only in each of those rows, but now they would have to appear in each of those columns once each, because we've only got 3 columns and we've got to use 3 8s and 9s. So these specific cells would already have used 8 and 9 in that circumstance, and this would be broken. That's lovely. That's lovely. That's how we know that this does not add up to 11. This is where the degree of freedom is taken. These add up to 12. These add up to 12. It's very hard for me to pencil mark this, so we're just going to try and remember it. The yellows add up to 45, the sum of the row, minus 12 the circles and 12 the arrows, is 21. And again, I can't really pencil mark it, but let's try and remember. The yellows add up to 21. What I can do is take out the degree of freedom from pink because we've used it in green. That is a 9. The degree of freedom has gone, so these aren't. There's our first digit in the grid after 10.5 minutes. And these yellows add up to 21, and we know more about, do we? This digit can't be 7, 8 or 9 because they've gone in this column. So that's a maximum of 6. Let's say 6, 5 or 4. These ones, once that's a 6, these add up to, well, they add up to at least 15. So they're either a 7, 8 pair or a 6, 9. No, they can't be a 6, 9 pair because that would have a second 6 in the row. Excellent. So if they don't add up to 15, it's because they add up to 16 or 17. They're always using digits from 7, 8, 9 once that one is not. Because these yellows have to add up to exactly 21. And once that is 4, 5 or 6, there's only room for one middly digit and no low digits in the 21 total. So we've got 7, 8, 9 triples down the outside now, and that's probably what we were aiming for. No, we've got better than that. We've got an X-wing on 9s We've got a 9 somewhere in row 2 in one of those cells because this one can't be. We've got a 9 in row 8 in one of those perimeter cells because this one can't be. And that means we're using up 2 9s already in the rows and therefore in the columns. It's either an X because it's either those 2 on the diagonal are 9s or those 2 are 9s. And that's why we call it an X-wing, because of the X that makes in the grid. Now, the fact that one of these cells is the 9 in column 1 means that's not a 9. One of these is a 9, so that's not a 9. So that's now a 7-8 pair, and the yellow cells had to add to exactly 21. So that digit becomes a 4. Now, 9 in this row is going to go in one of the circles, and the circles add up to 12. So they're 9 and 3. So one of the arrows is a 1-2 pair, and the other doesn't work. Oh, I've done the maths wrong. Oh, gosh, I'm so sorry. Right, 7-8 was correct there. But 7-8, it's 8 plus 9 plus 4 equals 21. 7 plus 8 plus 6 equals 21. So that's a 6. This is still a 9-3 pair. These are a 1-2 arrow and a 4-5 arrow. Sorry, maths eluded me suddenly. Now, the biggest digit we can put in here, which sees 7, 8 and 9 in the column, is a 6. And the same's true here. So I'm going to put 6, 5, 4 or 3 there. I just think it's interesting. Can 7 and 8 feature on these arrows? Yes, because 9 could be here. Okay, this may be mistaken. I'm going to get rid of the yellow. I think it's done its job. I'm going to leave the pink. But I'm going to get rid of green now. That's done its job. I want to colour the whole grid in the cells that can't be 9. There's been a 9 in column 1. There's been a 9 in column 5. There's a 9 somewhere in column 9 in one of those two. Now, in the row, well, all of these arrow cells can't be 9s. And that's what I was sort of thinking about. What else can't be a 9? We cannot have a 9 on this renban because these digits can't be 9, 8, 7 or 6 because they've all been used up in this column. So the 9 in row 7 is in one of those two cells. Now, is there a reason that renban can't have a 9 on? Probably not. These can't be a 9 because in rows 2 and 8 and in row 5, so is it about these columns and where 9 is going to go? Might be. I'm not sure yet. Right, there's a 9 in each of these pairs because one of these is a 9, one of these is a 9. That's 2 9s for the row. The 9 in row 1 is going to have to be in this box. One of those two cells is a 9. These are all blue. Oh, there's another blue cell that I haven't marked blue. And what about down here? One of these is a 9. Oh, look at this box. Where's 9 in this box? We've got a lot of blue, so it's got to be in one of those cells. None of these are 9. They're all in the same box with a 9. Oh, there's all sorts of stuff going on here. Right, there's a 9 in one of those cells, so these are all non-9 cells. This was a good idea, this colouring. Now, we know that one of those is a 9 in that row, and we know that one of those is a 9 in that row. So this is a little pair. Oh, beautiful. We get a 9 onto this renban. Okay, I'll deal with that in a second, but we also now know that these don't have a 9 in. And in fact, in columns 2 and 8, it's very similar to here, where this is an X-wing on 9s, even though it goes across a box border, even on the rows. That's the same here. One of these two is a 9, one of those two is a 9. Basically, we've done one 9 in the grid, and we've got a whole bunch of X-wings for the others. We've got one there, one here, one in these pink perimeter cells, and one here. That's weird. We can't disambiguate those. But I'm now going to get rid of blue because we've marked all the 9s in the grid. It did its job splendidly. And the job, I think, was mainly centered around ensuring that we now know this renban has a 9 on it. So the other digits on this renban are 7 and 8. And this one can't be a 9. So in this row, oh, one of these circles is a 9. So we can definitely still put 7 or 8 on one arrow, can we? I don't rightly know. Something's going on here. If that was, oh, this is not a 9, because this digit on this renban cannot be 7, 8 or 9 because it sees all of those. So that's not a 9. So now there's only one place in column 3 for 9, and it's here. And that gives us that this is not a 9, and therefore the 9 on this renban is here in column 7. Now this is not a 9, so the 9 in this row goes in this circle. And now this is not a 9, it's a 3, and the 9 in this row goes in this circle. And now in this row, we unwind the 9, it's over that side, and this isn't 9. And that enables us to come down here and say this isn't 9, and this is 9. And we've unwound 3 of our 4 X-wing pairs. We can't solve this one yet, as far as I can see. Now, we've ended up with a 7, 8 pair. We've got 9 here, which is a 4, 5 pair on the arrow. 3 there has a 1, 2 on its arrow. These 7 and 8, they're different from each other. I don't know. I mean, this is wildly speculative, but if we coloured them against each other, it enables us to see that none of these cells can be 7 or 8 because they see both colours. That may only be of relevant interest because this can't be 7 or 8. This is maximally 6. That one is maximally 6 as well because it sees 9, 8, 7 in its box. So the digits on the 6 arrows, that the arrows with maximum 6 that we found, have to be lower than those. Over here we can't have 3 in the column. I know this might be too much pencil marking, but it's quite interesting that these have ended up being pretty low digits. There is a 6 in this row somewhere. Is it in one of those cells or on the arrow? I mean, we might have to think about 6. No, I haven't thought enough about 7s and 8s. Right. I'm going to get rid of these pink colours now, I think. Yes, there are 7s and 8s involved, but I'm hoping to colour them differently. Now, I can't colour these yet. I've got red there and yellow there. So I don't know about these. One is red and one is yellow. However, whichever one is yellow sees another yellow there, and the third yellow in these columns must be here. So that has become 7 or 8. Red is there and up there. This is red. That's where the red goes in column 8. Now, I'm very interested, and I keep thinking about the question of where does 7 and 8 go in this row? Well, these cells see both red and yellow, so they don't go there. What do I mean by they see them? Well, you can't put a red cell on its own arrow because it's got to add to something else, and then that won't make red. And obviously yellow sees them in the row. So the red 7 or 8 is in one of these cells. Now it can be on this arrow, but it might also be here on the renban. Oh, we've also got 7, 8 here. Okay, I'm going to think about this triangle. Oh no, look, we've got 7, 8 up the central column as well. Yeah. So neither of these digits can be 7 or... Okay, the first thing I'm going to say is we cannot put 8 on this renban, because every cell on this renban sees this digit. If 8 was on this renban, that would be a 7, and then you couldn't put 7 anywhere on the renban because the relationship goes, it's mutual. This digit sees every cell on the renban. So you can't put 8 on here. So we're looking at the range from 7, 6, 4, 5. Why am I doing them in that order? 7, 6, 5, 4, 3, 2, 1. And that means there is a 5. If you take any set of 4 of that 7-digit sequence, you'll always have 5. So there is a 5 on this renban. That's probably not enough to do anything with. I have a feeling I ought to be able to prove there's no 7 on this. If there was a 7 on this, that's an 8. There'd also have to be a 6 on it, which couldn't be in those cells. So in fact, this would be a 7-6 pair. That would be a 5-4 pair if there was a 7 on this renban. I'm not sure where that leaves me. I want to colour more 7s and 8s, and I'm failing to do it. Okay, I'm going to use different colours for these. Instead of red and yellow, let's use green and pink. That's pink, that's green, that's pink, that's green. Just in case it triggers something off. One of these two is green, I can see now. So they are a 7, 8, 9. One of them is a 9, we learned earlier. Now we know one of them is green. So this is a 7, 8, 9 triple. That's a bit interesting. One of these two is pink. Probably in the circle. Don't know that yet. Anything else from that little excursion? Green is obviously green, and red and yellow we still have to match up somehow. I don't quite know. I don't know how to attack the rest of the puzzle. I mean, I've been feeling my way through it anyway, but now I'm getting a bit bogged down in my own thoughts. It's only 7s and 8s I'm colouring. I think this is interesting still. None of these can be red. I don't know what it proves. Could I say that's not red? That would be quite interesting down here, because red would... Oh no, that might be red. That's not so interesting. Where's yellow in this row? Oh, that's a great question. Yellow can't be in those cells because it's already been in this box. It can't be in these cells. That's a 9, that's not 7 or 8, and this one sees both 7 and 8. So yellow is on this line, and now we've worked out that 8 is not on this line. Yellow is 7, bingo. Red is 8. Oh, we've only got a few yellows and reds. That's not going to... Oh no, that's fine. 7 is looking at that cell. So green is 8 and is actually red. And pink is 7 and is actually yellow. And up here we have an 8-9 pair, which shouldn't be using green, it should be using red. And here we shouldn't be using pink, we should be using yellow and labeling a 7 in one of those cells. Okay, well that might change things. This can't be 7 because of that. This is now, doesn't have an 8 on it because that 8 sees all of them. So it is 7654. That is a 7-6 pair. This is a 5-4 pair. And in the column, I am now going to fill in a 1-2-3 triple. Ah, it's clever this, isn't it? It's really clever. I think I am missing the point about 6s at the moment, but I don't really know how to deal with that. Oh, this 8 pair, in fact, this lot add up to 17. I was going to say, and these two add up to 9, but we don't know that. I made that up. It was because, I don't know why. Maybe they don't. But they add up to 17. The 8 pair is either 3-5 or 6-2 because it can't be 7-1. Now, I know, I was going to say, well, in the rest of the row, we need to place 8 and 1. Yes. One of them is going to get onto the arrow, and that's going to drag the other one onto the arrow because once one of those is 1 or 8, the other one has to be. So that is a 1-8 pair. 8 is red and is in one of those positions. That's surprising. If that's red, that's red. If that's red, that's red. Nature is red in tooth and claw. In fact, I think the poetry quote is nature red in tooth and claw. Anyway. These are from low digits, 1, 2, 3, 4, 5. They see 9, 8, 7, 6. It might be time to start maybe mass colouring. Oh, hang on, 1, 8 was there. Do we know what? No, we don't know what that is yet. This can't be a 3. What about this line? It doesn't have an 8 there or there. Actually, it could still have one here. Except that neither of those could be a 7. So there is no 8 on the line. Well, that's quite interesting. Now 8 in the box has to be in one of these two cells. Yeah, if you... Oh, hang on. I may have made... No, that's okay. That can't be 8 and that can't be 8 because of the 1-8 pair. The only place 8 could be is here. And then 7 couldn't get on the line, so it wouldn't work. So 8 is in one of those cells. And 8 is therefore in one of these two, but no, we actually know where it is. It's here, and it's red. And these two are not a 7-1 pair. So again, we've got either 2-6 or 3-5. Now, 6 in this row, or... I'm just not seeing these other pairs in these columns as clearly as I was seeing the original ones that we used in the first set. Oh, that's not 8 because of utterly blinding Sudoku. Clear up your Sudoku, Mark. People do tell me all the time, and I would if I could, but I can't. Right, 1 sees this cell, that's a 2, that's a 1. These are now not 2s, and nor's this, so that's not a 6. Also, there's a 6-7 pair, so that's not a 6. Now we suddenly know this is a 3-5 pair. So over here we're selecting from 1, 2, 4. Yeah, there is something interesting about this, which I will get to in a second. And that is that, well, first of all, I'm going to say, what do those add up to? It's either 1, 2, 1, 4, or 2, 4. This can't be 4 anymore. But the more interesting thing, I think, is where does 6 go in this row? Because the answer is one of these two cells is 6. Now, in this row, can I make a 6 X-wing there? Or if not, can I make a 6 X-wing here? Don't know. Let me just think about this row. If 6 wasn't here or here, it would be because it was on this arrow. And that would only happen if you could also put a 1 on the arrow and a 7 there. You can put a 7 there, but you can't put 1 on the arrow. So 6 is not there. 6 is in one of these cells in row 2. And we have an X-wing on 6s. We have 2 6s at the corners of this group of 4. And now this digit can't be 6. Or this one. If this had been a, well, never mind if it had been a 6, it's not a 6. I was wondering if it has to be a 7 now to get the total for these cells up. If it's not a 7, it might be a 5. These two at their most add up to 11. And then these digits would have to be 1, 2, 3, 5. Which I think they can be at the moment. I'm not sure that'll last, but it does exist, so I haven't got the excuse to do anything. This digit is not 6 because of the double green 6. Well, that's good. This is now not a 4-2 pair, and 1 is in it. This is 3 or 5. That can't be 6 either from this column. Same deal. So 5 comes out of those as candidates. And now, if that's not a 7, it can't be a 6. Oh yeah, so obvious. The biggest total for those two, if this wasn't a 7, would be 5 and 4. And then these 4 cells would have to add to 9. Well, that's too many for 4 different cells. So that is a 7. And we can colour it and get rid of all the markings in this cell. That pair is not 6, 1 because 1 has gone. It's either 2, 5 in that order or 3, 4 in that order. So this digit is, well, one of these is a 4 in this box. We've got 2 and 6 there, 8, 9 pair there, 7. Those can't be 4s, so one of those is a 4, and now this one isn't. That is 1 or 2. What is my pencil marked 1 doing here? Is that right? Yes, that's because this came down to earth. Now, in this row, we don't quite know. If that was a 3, this would be 1, 2, 3, 4, and the greens would be 5 and 6. If that's a 4, this is 1, 2, 3, 5. And the greens are 4 and 6. If that's a 3, this is 2, 1. That's 4, 3. And the greens are 5 and 6. Oh, that didn't teach me anything. Right, down here where we had this, 3, 5 pair is making a 3, 5 pair in the column. 3, 5, 1, 2. Nine is at one end or the other. I don't know. I've only just noticed 8 is in one of those cells. That's a sort of X-wing with the 8 up here. What about 7? 7's in one of those two. It's somewhere here. That's not as informative as I want. Oh, goodness. Okay. Still need to focus and concentrate and get something done here. It's going well, but it's tricky. 7, 3, 9, 8. We need a 6 in this column, which we know is in one of those cells. So this also can't be a 1. This is 2, 4, or 5 on this renban, which is much lower than this counterpart renban. Now, what else do we know? We know that 1 in the box is in one of those 3 cells. That's not... Oh, we know that 7 is in one of those two. Oh, my goodness. Can this be 7? It would have to be 6 here, 5 here. That would be 4 or 3. Oh, this it couldn't be 4. This can never be 4 because this can't be a 1, 3 arrow. So if that's a 7, 6, 5, 3. I'm sure it can't be a 7, but I can't quite work out why. Oh, well, hang on, there's more ramifications. 7, 6, 5, 3, and in the row we've then got 3, 5. That becomes 2, 6, and that becomes 4. 1, 3 there, 5, 4. Oh, it works. That's so annoying. Why does that work? That's not fair to me. Oh, I've got to find something else to do that I have not considered yet. Oh, botheration. It's so clever, this. Why don't I know what's going... Maybe there's some digit that can only be in one place in this row. This row's suspicious. Let's just think about, if this was 3, 5, that would be 6. That would be 4. This would be 2. That was 3, 5, and this was 6. This would be 2. Well, that would have to be 1, 5 in that case. One 5 sitting under a 2 here. So if that's 3, 5, this is the case I'm going at here. That's a 6. That's 4, that's 2. This is now 1, 5. So we've got 6, 2. 3 is going to have to be on this renban with either 1 or 4. I don't know, I don't think it explodes the thing. Not quite. It's tricky, but it still keeps working. Maybe I should have coloured green for 6 elsewhere. Actually, I'm going to do that. So first of all, I'm going to say these are X-wings, so they're not certain 6s. But if 6 is green, we can put green into those cells. That's obviously green already. We found 1 6 in this puzzle. Now, there's a 6 either in those or in those. And down at the bottom, there's a 6 either in those or there. Well, that's quite like an X-wing, isn't it? If we've got to put 2 6s in these positions, and we do, yeah, no, but we're not putting 4 of them in. I don't understand. Oh, if one of these is a 6, it takes it out of here. Ah. So if a corner is a 6... No, I don't know. I don't know. There's no reason to speculate on that specifically. I haven't got the wherewithal to do that. What I should do is do something ordinary, like add up these again. If that's not a 5, these add up to 10, and that's a 3. And if that's a 3, this is a 1, 2 pair. That's 4, and that's 5. So if this isn't 5, that's 4. So 3 would go with 4. 5 would go with 2. Obviously, it's a 7 total. Why can't I use some common sense occasionally? 7, 3, 9, 8. This can't be 5. That's quite interesting. No, it's not. No, it's not. In this row, though, one of these is a 6. The other is 2 or 4. I mean, that's quite interesting. If that's 2 or 4, this is a 1, 2, 4, 5 quad, and that's a 6. It's not that interesting. Oh, what about adding up? I wonder if I can get these from just adding up something. if that's 3, 5, that's 6, that's 4, then these add up to 10. Is that useful? It doesn't really feel useful. The 3 would be a 1, 2 pair. The 6 would either use 1 or 2. It would X-wing 1s and 2s, some in a bit. No, I don't know. Okay, what if that's 2, 6? Maybe there's a problem there. It feels less likely. These would be from 3, 4, 5, and that would be 4 or 5. Hang on. Either, if that's 3, 5, we've got 6 there and 4 there. But if that's 2, 6, one of these is a 3. I can't quite work out the ramifications. Oh, goodness. Sorry, I'm being a bit dense now. How about down here? We've had 8 and a 6, 7 pair. Down here, no, I was going to say we're working with 9, 4 and 5, but that might not be true. If that's 5, that's 4. If that's 5, that's 4. If that's 3, this is a 1, 2 pair. We have to have something low on here. Even if that's a 6, we must be using 1 or 2 here. Oh, does 1 have to be used here? Yes. I mean, this is not an enormous thing, but it actually matters a tiny bit. 1 must be used on this arrow, because if it wasn't, it would be a 2, 3 pair adding up to 5, and that would be a 4 and a 5, which adds up to the wrong total. So 1 is being used there. This digit is not a 1. Where is 1 in this column? It's definitely on this arrow. And that's why I got excited about that. I'm not sure it does anything, but it is true. Now, what could I use that to mean? If that's a 1, that's a 1. I don't know. There is a 1 in use on this arrow. It's either 1, 2 with a 3 there, or 1, 3 with a 4, 1, 4 with a 5, 1, 5 with a 6. This can't be that low. It's because of these having to add up to no more than 12. They must use 1 and 2. So 2 also cannot be there. Now, if that wasn't 6, this would be a 3, 4, 5 triple. 6 would be there. That would have to be 2 and 1. So if that's not 6, this is a 3. That's an oddity. Alternatively, that is 6. And then what? Then this is 2 or 4. Then that's 6. So both of these being 6. That would put 6 in this corner. And in one of those cells. I'm just going to think about this for a second, because I can't find another breakthrough at the moment. So I've got to just worm my way into the puzzle somehow. Goodness, I'm feeling a bit less than intelligent at the moment. This is 4, 5 or 6. It can't be 2 for the same reason that that can't be 2. And one of these is 6. And the other one is going to help determine what these add up to and therefore what that is. I don't really get it. I don't get how this works. What if that's... Okay, it's quite interesting if that's a 3 at the top of the grid. Because these all get put into place. 5, 4, 1. 2 there to make the 7 total. So you've got 5, 2 there, 1. I don't know, but the 1 that we would put in here makes that a 2, which forces this to be a 1. And if that, whatever, if this is 1 or 2, it forces the same digit to be there and there. That's quite interesting. So maybe the game is stopping this being a 4. Well, that's a little more powerful than the things I've been doing elsewhere. If that's a 4, that's a 4. I can see that. I can't quite see what else to do. Oh, this is interesting. If that's a 4, this is 5, 3, 1, 4. If that's a 4, that's a definite 4, and this is a 1. So if that's a 4, this is a 1, and that must be 2 down here. Well, that's quite a lot of power. That's, if this is a 4, then that's a 4. I've got 1, 4 there, 2 here, 3, 5, 6 in the rest of the column. Oh, what does it do? This is quite interesting. If that's a 4, this is 4. And 1 there makes this a 5, 2 pair. We'd have a 3 here. We'd have 4, 1, 3, 5. Oh, that would break this cell. My goodness, that's quite hard to do. I'm sure this isn't the official next step, but it works. If this was a 4, that's where 4 goes in box 2. And that has to be a 1. Now, if you've got 4, 1 there, you've got 5, 2 here. That's 6. This is 3. And if you've got 4, 1 here, this is 5. And if you've got 5, 3 here, you can't fill that cell. That'll do for me. This is not a 5. Neither of those two. Sorry, this is a 5 because it's not a 4. So those two aren't 5. This is 4. Now, this had better work. This can't be 4 anymore because the circle won't allow it. Now these add up to 10 or 11. So these are 1, 2, 3, 4 or 1, 2, 3, 5. That doesn't do anything new. Come on, 5. This can't be 5. So this can't be 3. That's a 1, 3 pair. This is the only place for 5 in the box. That's a 2. Here we go. This can't be 5. Also, this can't be 2. We've now got a 1, 3 pair on the arrow and a 4 in the circle. And this can't be a 3 or a 4. That's a 6. And that is coloured, my friend. That is green. These ones are not green. That's a 4. This is 6 down here. This is not 6 or 4. That's a 2 apparently. And I can almost add these up. These are either 1, 3 or 1, 5 now. And that is 4 or 6 in the circle. We should be able to circle back to that in a moment. We can take 4 out of these. Nearly got some sort of quad or triple or something there. Never mind about that. Let's look at 5, 6 as a pair here. These are from 1, 2, 3. Got to be some pencil marking going to pay off in a moment. This is 2 or 5. I think this renban was probably the better key, and I didn't really investigate it quite as hard as I should have. So the thing I found was a bit funky. I know that, but I loved it. I still enjoy finding stuff like that. So what are we going to do next? We're going to, I don't know, I've got that 1-3 pair. That hasn't got resolved. Something has got, I mean, there's been a lot of Sudoku digits going in lately. So if that was 2 and 5 have now been used up between those cells because one of them's there and the other one's on this arrow. So that's not a 5. That's 3 or 6. Now 1, I could have worked that out before. 1 is definitely on this arrow. That's an X-wing with this arrow. There can't be any other ones in the rows that they're in. 1 in this box is in one of those 2. That's just known now. Oh, something in row 5. Come on. If that was 3, 5, you've got 2, 6, 4. And that 3 would make this a 1. So if that's 6, 2, oh, this is the only, look, that's a 2, 3, 5, 6 quad in the row. This is a 4. So that's a 1, 3 pair, and this digit is 5. And now that is a 4 with a 1 here. I could probably have got that 4 in this row just as simply if I'd noticed it. This is not 2 or 4. It's also not 5. That's 3. That's 1, that's 3. I've got a 6 in the corner. I did mention earlier that if we got those 6s, we'd get a 6 down here, and I forgot it entirely. So one of these 2 is a 6. That's not a 3. These are from 1, 2, 5. This is also not a 3, so that's not a 5. That's now a 2, 6 pair, so I can fill in 3 and 5 over here. The 3 makes this a 1, 2 pair, and I know the order because I've got the 2 on the other side of the grid. This is not 2 or 3. That 1 sees this cell. It's coming now. I'm not scared anymore. One of those is a 2. Well, it can't be on this line with a 5, so it must be there. That makes this a 5. That makes this a 4 on the renban. I've got 6, 7, 8 still to place in this row. That one is 6 or 7 on this renban. That's not really getting itself fixed for me. 1 in this column is down the bottom now. That can't be a 1, and there's only one place in the central column for a 1. That's going to deal a blow to the low numbers in box 3. This becomes a 1 over this side of the grid. That's 2 or 6. That's a 3 in its box. That's a 5. That's a 4 in its box. The 5 has made this digit a 6. 5 there. That's now become a 7, and the renban needs a 6, which is also luckily what the column needs. That's a 3. Okay, I'm going to get rid of all the colour now because it's really done a decent job. Now that's become a 2. That's a 3. In this row we've got a 9 and a 4 to place. The 9 goes up here where it's sharing space with an 8. The 8 is sharing space with a 6. The 6 is sharing space with a 7. This digit's 2. And we've got 2 cells left to complete the puzzle. 5 and just under an hour. 7 there. 2's company, 3's a crowd. Congratulations, you have solved the puzzle. Am I getting better at setting Sudokus? I see the pun. And the reason it was 2's company, 3's a crowd is because we were originally comparing 2 sets of 1 to 9 with 3, which was probably very obvious to you. Lovely puzzle. I find it pretty difficult. I'd like to know what the step was. Was it to do with this renban when I was faffing around with 4 and 5 here and eventually broke in? I don't know. That was quite late on. That was a very good puzzle. Thank you for watching us on the channel at any time, but especially this puzzle. Great fun. And I hope to see you again soon on the channel. Bye for now.